Hello, everyone. Let's start with this webinar about our new release of PragmaDev Process version 3.1. So I will do a reminder, what PragmaDev Process is about and how it's uh, meant to be used and what for, and then we'll go through the demonstration of the new features. Okay, just as a reminder, the objective of the tool, PragmaDev Process, is to help BPMN modelers to verify and optimize their models. And in order to do that, we have four steps in our methodology. I will briefly go through the steps. With a short description. So the first one is, of course, to once the model is edited and defined, is to do a static analysis. The standard defines a number of rules so that the model is properly written. So the tool implemented all the standard rules, and you can verify easily and correct within the tool, so that in the end your model is properly, let's say, built. So it can be some very simple things like, do we have a start and do we have an end, or is that message that is leaving that participant reaching that other participant? So is the other participant expecting the message? Things like that. Sounds pretty simple when you say it like that, but actually in the real world, processes might be very complex and might be written by different teams and people, and you might get some unexpected result. Once the model is properly written, then you can do some dynamic verification. To do that, we have an execution engine that is based on the BPMN execution semantic. And that allows the user to go step by step in the model, following what is possible in the execution. Because sometimes, the symbols are confusing and you think you wrote maybe a parallel execution, and actually it's exclusive execution, so it doesn't work. And the way we do that in the tool is that we show, you can see here in that, I don't know if you can see, I think yes, you can see, where you are in the execution, and it shows you exactly what you can execute next. So you cannot execute something which is not allowed. There's no interpretation, there's no implicit understanding of the model, because that's very often the case in real situations. So that allows you to make execution scenarios, record them. Here you have record with an MSC. The MSC allows you to replay it if you want. So if you modified something, maybe the scenario has to be still valid or is not valid anymore. Maybe you have to do some correction. And also you have a coverage information that shows you if you forgot to execute some of the path in the model. So static analysis, dynamic execution. Third one is exploration. Since we can execute the model step by step, you click wherever you can click. Sometimes you'll have several choices. Well, the tool can do it automatically for you. It can execute randomly, exhaustively, all the possible path of execution. And for that, we have a collaboration with a research lab in Brittany, Insta Bretagne, and we interface with a tool called OBP to drive the exploration of the model. So what's the point of executing, I would say, dumbly, randomly, all possible execution paths? Well, first, that gives you an idea of the complexity of the model, because if you have a huge number of path, of execution steps, that means your model is complex. So is that normal? So sometimes it is, sometimes it is not. Usually models should be quite simple. It's an abstraction. It's meant to be simpler than somehow the reality. Anyway, another thing is, can you execute all execution paths? You have defined a model. Can you go everywhere in the model? Maybe you have some unreachable path, and that's a problem, of course, because that means that they're useless, basically. Also, do you have a deadlock in your model? Maybe a participant is waiting for something from another participant, and the other way around. So they're waiting for each other, and nothing happens. It might be a situation like that, and that happens more often than one thinks. And more advanced feature is property verification. Something that should always be true or should not never happen can be verified in all situations. Last but not least, the optimization of the business process. So to do that, you have to add, of course, some timing and cost information to the model. And that is done using BPSim, which is a standard which is closely related to BPMN. And what you do is that for each activity in your BPMN model, you add some timing information or cost information. So, for example, you can, okay, this assembly takes 40 days, for example. And you also say that you need some specific resources to do that activity. Maybe you need a machine, maybe you need specific skills from engineers, and these resources, they have their own agenda, because they maybe they're not there they're not there on the weekend, maybe they're not there on Wednesdays or Friday afternoon, or maybe they have a training, maybe they're on holidays. So and you put everything together, and that is taken into consideration during the execution of the process. Now, what happens is when you put this statistical information, timing information, because of course the timing information, I forgot to say that, but they can be a fixed value, but they can have a statistical distribution, okay? Because it's not always a fixed value. And if you have a statistical distribution, you need to run several times the scenario to converge. And when you execute, actually, all these statistical information, even put in the branches and in the activities, drives the scenario by itself. You don't have to click, okay? Because you know which one is shorter, and the statistical distribution or the gateway. Gateway is when the path splits. And so the execution runs by itself. What you do, you repeat that thousands of times to converge statically. And then in the end, what you get is a statistical evaluation of lead time, the time spent to do the whole process, or maybe a part of the process, or the number of times you executed an activity, and so on. You decide what you want to target. And of course, that provides you with a distribution for the result. And it also shows you the usage of your resources. Maybe you are underusing your resources, or maybe you're missing some resources. And then you can analyze it, you see, graphically, and correct, and maybe allow some more resources, reorganize the process, or whatever. I said there are a lot of repetition of the execution. You have the logs of each execution. So if one of the logs, one of the statistical, let's say, execution is strange to you, you can replay it step by step and find out, analyze what's going on. Also, you can have a visual representation of the critical path. So if you want, that's very helpful if you want to optimize your process, of course, because it shows you what the critical path is. So there's no point in improving something which is not on the critical path to improve the process. So that's why my 10 minutes introduction to PragmaDev Process with the 4 steps of in our methodology: static analysis, dynamic analysis, dynamic execution, sorry, exploration, and simulation. Of course, now the question of the model is to write the model. It's not sometimes easy to write. So that's why we have improved our editor to be able to ease the edition of models. For that, Eric will take over and present you what we have done for this new version. Eric, your turn. We cannot hear you, Eric. I think your mic is.
Hear me?
Okay, good.
Thank you. So here is our editor. So it's been like this since the first version of PragmaDev Process. We had, of course, editing features. The regular way to create a model in previous versions were via either the symbol insertion toolbar here. So you could select, for example, an activity, select the exact type of the activity you want to insert, and then drop it in the model.
Excuse me, Eric. Are you showing something on your screen?
Sorry.
Yeah, that's what I thought.
This is okay. It didn't work. Can you see it?
Yep, we got it.
Thank you. So, as I said, the old way of creating processes was to use, for example, the symbol toolbar here. So you could select category and activity here, the exact type of activity you wanted to insert, and then drop it in the model. This was pretty straightforward. We had introduced too the possibility to insert symbols with keyboard shortcuts, but well, that was not really practical. It required you to remember all the shortcuts for the different kinds of symbols you could insert. So in version 3.1, we decided to make things a bit more practical. So now here is a process that is not really finished. So we'll see how you can now insert symbols in a much easier way. So, for example, when you hover over a symbol, an existing symbol, you see that you have little buttons that appear on the side of the symbol. We'll demonstrate first the middle one. The middle one is for directly creating a successor without having to go back to the toolbar here to insert something. So you just click the mouse button here, you pull to the location where you want to insert the successor, and when you release the mouse button, you'll have a little menu that will appear that offers you all the different symbol kinds. So here you have activities, call activities, gateways, end events, and intermediate events. So here we want to insert an intermediate event. So we click here, and we have another menu appearing, which shows you which asks you for the exact type of symbol you want to insert. So here we want to insert a message catch. So you always have a tooltip to know exactly what you're inserting. You just click here, and the symbol is created, and the sequence flow is created also automatically. So type a simple text. That's the first way to create, to make the addition of models much easier. So usually that's the main thing that you have to do. You create the first symbol in your process, and then you can just create its successors just by clicking this button and pulling, and you just create them in a row. Sometimes you also have to create explicitly a sequence flow, for example. This is the case where you want to make a loop like this one. So that's what we'll be doing here. And you can do that via the buttons on the side of the symbols too. So you can just click here, that for the creation of a sequence flow, you click here, and then everything happens just like the insertion of regular sequence flow. So here we want to directly create a broken sequence flow. So I press Shift on my keyboard, and then I press on every corner, and that creates the sequence flow just as I want it. So what I demonstrated here for sequence flows, of course, you can also do it for message flows. For example, there should be a message flow from this activity to the start symbol here. So this is the third button here, showing a little message. So you just do exactly the same. You just press here, you pull down to the destination symbol, and you release, and you create a message flow. Here, so that the first thing, probably the most important thing we did to make the creation of BPMN models much more practical than it used to be in previous versions. We also added a few other things, especially regarding containers, so participants and lanes. So before you had to adjust the size of the participant around a process. If you wanted it, the process to be in a participant, you had to adjust its size manually. You no more have to do that. So, for example, if I create a participant and I put it here, so the start symbol named Hungary will be in the participant, but a participant contains a process. So it should also include all the symbols in the same process as this start symbol. And if I drop it, it actually resizes automatically to include everything. And not only does it automatically include everything when you create it, but when you start adding things to it, it will adjust its size automatically too. So for example, let me create a success of this event gateway. So we had it here 30 minutes, and we'll create another intermediate event for a message reception like this. And you see the participant adjusted its size to include the new symbol that I just created. So that's for the participants. We also made sure that we made the handling of lanes within a participant much more practical than it was in the previous versions. Let me show that here. So here we have an empty participant. This is the very beginning of the creation of the model. If you create a lane within this participant, now what will happen is that the lane will automatically adjust its size to fill the whole parent participant. And if you resize the participant, the lane will be resized with it. If you want to create another lane, this is also much more practical now. So you can, for example, right-click on the existing lane, and you can say add lane after, for example, and the lane will be created right under it. The other possibility is to right-click on the participant, the parent participant itself, and you have add lane at first position and add lane at last position. So if you create a lane at last position, this is how it happens. So now that you have lanes, you can also, if you realize that one lane is actually no more needed, you can select two lanes and ask to merge them. So basically, it will take the two lanes and their contents and will put that in a single lane, which will have the name of the last selected one. And of course, the lanes always adjust to their size, to the size of the parent participant, and if you create symbols within the participants, even if you resize them, the participant itself will resize itself, and the lanes will also be resized automatically. So here is for the lanes within participants, automatic handling of this. We also introduced something for people who do not want to be bothered with lots of symbols in the BPMN. BPMN is rather simple, but sometimes there are things that people would not want to use. For example, there are many types of activities which may not be relevant for you. A lot of people just use plain tasks. So we have introduced here a specific mode which is called Simplified BPMN. The objective of this mode is to reduce the number of choices for the symbols you can create. So it will be even easier and faster to create simple models. So for example, if I switch to BPMN, I created a start symbol here. So that's just a start symbol. And if you create an activity, for example, there are many types of activities. In full BPMN mode, you would have a secondary menu asking you for the exact type of activity you want to insert. But here, you just have a plain task, which is usually what people want when they do simple models. Same thing goes for call activities, for example. Most call activities are process call activities because that's really the mainly used ones. So you won't be asked for the type of activity to insert, and we insert a process call activity directly. The thing being, it doesn't reduce a number of symbols that are available, just the one that you're offered when you create one. So you can always ask for the properties of the symbol, and if you want occasionally something specific, you still have in the menu here, you can change the type, the exact type of task to the exact type you want. If you really want to need, if you really need another type of activity in your model. So here it is. I've covered pretty much everything we've done for this version for the modelization. So I'll give back.
Thank you, Eric. I'm pretty sure that will be very useful and make your edition of BPMN very efficient. So now we're gonna talk about multi-core simulation because some of the models the tool has to handle are quite large, and simulation can be quite power consuming in terms of a processor. So now I leave it to Michal to present this new feature about multi-core simulation. Michal, don't forget to switch on your mic. Now it's your turn.
I already did. Already. So hello everyone. So let me share the screen also. I would like to go briefly first as an introduction to all the most important parts of the simulation, and then switch to the new feature of this version of PragmaDev Process, which is the multi-core simulation or parallel simulation to speed up the execution time. So here I have a pizza delivery model with basically two processes, one for the customer, one for the vendor. So the customer decides to order a pizza, and the vendor, composed of a clerk, chef, and delivery boy, is responsible for taking the call, handling client requests, the chef for preparing the pizza, and the delivery boy for delivering the pizza to the customer. So in order to do some analysis of the model that is time related or cost related, first we have to enrich the model with time and cost information. So for example, just going briefly, if I go to simulation properties of the activity make the pizza, you can see here that we introduced some timing information, namely the processing time. So for simulation, we've opted here for a triangular distribution with average value of mean value of 10 and minimum value of 8 and the maximum value of 15 minutes. The same can be done for all the activities in the model. So here we have another activity with other values. Second important point to further enrich the model is to make sure or attach resource requirements to these activities. For example, for the make the pizza, we can say that this activity needs one resource with the role chef, for example. And during simulation, the simulation engine will check this criteria and try to get the resource available with the role chef. So for the resources, we can define them in a PragmaDev process via the resource editor. Here we can see we have defined two types of resources, one named cook and the other one unqualified. For both of them, we can edit the quantity. So for each of them, for simplicity, here we are opted for one cook and one unqualified resource. And we can also define the roles, which is here important because we want a role, we want a resource with a role chef to attach to the activity of preparing the pizza. So here we have three roles: the chef, the clerk, and delivery. And after defining the roles, we can attach to each of the available resources the roles that we want to attach to each of them. So for example, for the cook, it may be responsible for preparing the pizza, but also answering the requests from the clients. And the unqualified resource is responsible for handling client requests, but also for delivering the pizza to the client. So this is a general overview. This was already available in the previous version of PragmaDev Process. So before launching the simulation, for a simulation, we can define several scenarios. So in this case, I've defined two scenarios. One, well, the difference between the two is just the delivery. Here, the activity, the call activity delivering the pizza, which means that one, in the first scenario, we suppose that the delivery is done by bike. So you can expect longer times of delivery, but lower cost. And also delivery done by car, which is the opposite, meaning that we have higher costs, but lower times of delivery. So let me launch the simulation for both of these scenarios here selected. So I will run a simulation, and you can also pay attention to the time of simulation because this is important for later. So for each of those scenarios, I've opted for 100 replications. For each replication, there are 10 tokens, meaning 10 instances of pizza order from a client. So now that the simulation is done, I can save the results. So it takes just a little bit because we have many log files that have to be generated. So if we see in our project, now we have a new file of simulation results, which is added to the project. So we can double click and open it. So first of all, it will open the same model, but now in read-only mode. And now we can analyze the results. So if I go and right click, for example, the activity make the pizza and go to simulation results. And here I can click the parent process results and show the values. Here I have requested to show the cost, the total cost of the process. Of course, this is a distribution because the cost depends also on the processing time of the different activities. So here we have the two different scenarios with different colors, the blue and the green one. The blue one is the delivery by bike, and the green one is the delivery by car. So we can see that the cost is lower for the delivery by bike. If I can switch to the time, meaning the total time for the delivery of the whole process from getting the request from the client to the delivery of the pizza. And we can see both of the scenarios once again. Now, here the times look very similar, but if we go deeper and, for example, check the results of the current customer, meaning that how many times we needed to go and say to the customer that the pizza is on its way, meaning that the delivery took more than 30 minutes, we can see that there is a difference. We can call this, we can see this as a quality of service. We can see that with the bike delivery, we had to deal with many more customer complaints compared to the car delivery. Also important, we can check also the use of the resources. So let me make this bigger and just make it to fit. So here we can see for each of our scenarios, the utilization of the resources for each of the activities. So there are different views. I will not go into all of them in detail, but this is just to show that you can also analyze the resource utilization for each of the scenarios and each of the replications. Other important thing and feature of PragmaDev Process is to automatically compute and show in quite simple and readable way the critical path. So meaning that which of the activities are critical to the whole time of the process. So this is here shown by colors, meaning that the green color means low probability in appearing in the critical path, and red one is a high probability, meaning that changing or trying to improve the tasks in red will almost certainly affect the total time of the process. So having said that, switch back to the model, so I will close the results. And now the new important feature for this new version of PragmaDev Process is that we can basically do the same, have the same results, but faster. Meaning that if we go into the preferences of PragmaDev Process in the tab Executor, here we have a new entry which says number of CPU cores to use for parallel simulation. And now from 1, which was the first case, I will go and opt for 4 cores, apply the change, and I will relaunch the same simulation. So if I run it again, we can see that here it goes much faster, of course, because it tries to leverage all the physical cores in the machine. And the scaling in terms of performance depends on the size of the model, the number of replications, the number of scenarios. So there are many factors. But usually, for example, for 4 cores, you can expect a minimum of 2 times gain in terms of performance. So as we can see with this result. So I will not say them again because they will be, of course, the same. That is one of the most important things, that we should ensure that the results being, even if we run them with a single core or multi-core, they will be always the same. So the good thing is that for big models that have many elements and have all of them enriched with simulation information like time and cost, this can help a lot in speeding up the simulation times. And we have observed that with a machine, with a normal machine like a laptop, we can have gains at minimum 4 times for real industrial examples, using a laptop with 8 cores. So that is it for this part of the demonstration and this new feature of PragmaDev Process. So I'll stop sharing.
Okay, thank you, Michal. So we are a bit late, and we're almost at the end. We won't have time to discuss any further. I think we have to wrap it up. So if you have any questions, the best is to send your questions to support@pragmadev.com, and we will answer the questions we see here directly using your connection information to the webinar. So thank you all for participating, especially Michal and Eric. And the replay will be available shortly on our website. Thank you. Bye.